My mom is a math teacher and my dad works for the EPA, and so I was kind of always surrounded by science and math growing up. And I was also encouraged in my high school, which focused a lot on science and math, to participate in a research internship during a summer between junior and senior year. It gave me the opportunity to have hands-on experience in science and technology, and it gave me a little bit more of a perspective on seeing the application of what I learned in a classroom in actual real life research. And so I really enjoyed that. So I decided to continue on to get my biomedical engineering degree at the University of Michigan. And then I decided to even stay a year more to get a research-based master's in tissue engineered cartilage research. So I just kept enjoying the research that I did. And then I also started to explore my passion in teaching and mentoring. And so with all those combined together, it seemed pretty clear that I wanted to pursue a PhD. And so I decided to go to UC Davis for my PhD in biomedical engineering as well, and continue my journey to becoming a professor. My project has focused mainly on a neurodegenerative condition, spinal cord injury, which affects a lot of people all over the world and causes a lot of tissue damage. And it's, depending on the severity, can also lead to paralysis. My work has focused on using these small particles that are on the nanoscale, and they're called extracellular vesicles, or EVs. And they're like the natural post office that it's being sent packages back and forth between cells all over the body. And so they can tell cells that are far away from each other to change their behavior in some way. So that could mean to grow new blood vessels or to try and save cells from death. So we're seeing a lot of these EVs have a natural regenerative property. And so my project basically aims to use chemical reactions to modify the surface of these nanoparticles, or EVs, with a specific molecule that binds very specifically and with high affinity or high strength to a specific type of cell that's in the spinal cord. Basically, my whole project is to improve the targeting efficiency of these regenerative nanoparticles, or EVs, to the spinal cord so that they can both get to where we want to go and also create that regenerative environment and prevent, hopefully, even more irreparable damage to the spinal cord. Financially, it's wonderful being as I am a PhD candidate. It's been really helpful to keep me going. The foundation has already provided other resources as well. I participated in their communications training to help us all better communicate our research to either a lay audience or an audience of very diverse technical backgrounds. All in all, I think teaching, mentoring, and using research as a form of hands-on experience would be really great, kind of bring me back to my internship back in high school.